Science 10 and welcome. Lesson number 7, naming of covalent more molecular compounds. So today, in this lesson, you're going to learn about the importance of the IUPAC, how to write molecular formula names. You're going to have to learn the prefixes that go in molecular naming, as well as how to write chemical formula for molecular compounds. So let's start talking about just naming in general. So the IUPAC system is a system that ensures that all pure substance have a single and unique name. And this is important because we use it all around the world. So this is called a systematic name. So IUPAC is the abbreviation for the International Union of Pure and Applied Chemistry. And it names and the names in the formula that are come out of the IUPAC, like I said, are very important for communicating with people around the world. So when you talk about a chemical, you know which one you're talking about because they're all named the same way. Doesn't matter, regardless of the type of language. Now, sometimes they're a little bit different. Like, for example, sometimes you name them a little bit differently, for example, in French. But the idea is that the chemical structure that you see is the same. So when you name it, you're like, oh, that's what it is. So common names that are not the same in every country, but are systematic names that normally are. So for example, if we say a common name for something is salt, the chemical formula name for it is sodium chloride. So sodium chloride doesn't change, but the word salt may change from language to language. The common name of saltpeter, okay, is a common name that may not be the same around the world, but the chemical formula potassium nitrate is. So again, this is all it means is that when we're talking about things around the world, that we use this system to help us name things so we can communicate with other people in different countries. So let's get right into naming binary molecular compound naming rules or covalent bond rules. We're going to start here because this is probably molecular is the easiest out of the two. So let's just talk about what it is again quickly. Molecular is two nonmetals coming together to make a compound. So two nonmetals sharing electrons. So in order to start off with naming, so we're just going to name something. So if someone gave you the compound CO right here, we're going to name this. So we're going to start with the first element in the formula, and we're going to use the first element's name, such as carbon. So in this case, CO, the first element is carbon. So we just use its name and write it down. The second element, depending on what is here, will now have its name plus the IDE suffix or ending attached to the name of the second element. So in the case of this, instead of oxygen, it would be called oxide. Now, CO is not called carbon oxide, okay? That doesn't sound normal. You probably have never heard of carbon oxide, and that's because it doesn't exist. Because when we do molecular naming, we use things called prefixes. Prefixes are there to tell us how many atoms are present in the molecule. So an atom, remember, is the single element itself. We talked about the element of carbon. It's a carbon atom. We talk about oxygen. It's the atom of oxygen. But when it's in a molecule, it's together as CO. So when we're looking at carbon and oxygen right here in this compound, we have to look to see, is there any sort of indicator of how many atoms there are? This one has one, because obviously it's one carbon, and this one is one. This is one oxygen. So when we name this, we have to use those prefixes. So in this case, this stays as carbon because there's no number beside it, but this one becomes monoxide, mono for one. And that's because there's one oxygen molecule. So you may have heard of the word carbon monoxide before, and that is how you would name a compound like that. So here are all the prefixes, and I will be getting you guys to do a very quick practice on these. You need to memorize these. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should have mono, di, and tri memorized from grade 9. So now you're going to have to add in the last little bit. It is in your chemical formulas, like on your formula sheet, but if you want to do well in Chem 20, you're going to need to know these prefixes. So we might as well start practicing now. So let's talk about some examples of how to name. Okay, so here's my first example, C5H4. So I'm going to look at it and say, okay, I have carbon, but I have some sort of amount of atoms attached to it, so 5. So what I would do is I would go back to my prefixes and I go, okay, 5 is penta. All right. So when you name it, you put the prefix name first if it's needed, and it is because there is a number attached beside the carbon. You're going to put the prefix first. So penta, and then you're going to name it carbon. So this first part is pentacarbon. Then we're going to go, what is the prefix for 4? Tetra. Okay. So we write down tetra. Hydrogen is not the right name. We want to go hydride because remember IDE ending. So this is called pentacarbon tetrahydride. And that's how we name this. Putting the prefixes first, followed by the element name. The second element has to have an IDE ending. Okay. It's no different than when we're naming ions and we're naming anions, those negative ions, we call them the fluoride ion, the nitride ion. Okay, it's because we add the IDE ending. So let's take a look here. NO3. Looking at nitrogen first, noticing there is no number beside it. Since there is no number beside the first element, we do not need to use mono. Okay? If there is only one of the first element, we leave it as is and just call it by its element name, which is nitrogen. So this is just nitrogen. We now look at the oxygen and we notice there's 3 oxygen atoms. So we go back, try. All right. We write that down first, add oxygen with an IDE ending, and we get trioxide. So this one is nitrogen trioxide. The last one we're doing, P for phosphorus, I for iodine, but we have to make sure we add in those prefixes. So 9 is nona. So the first part would be nona-phosphorus. The second part would be hepta for 7, and iodide because we're adding the IDE ending. Now, the IDE ending is going to feel a little weird, and you're going to have to roll with it and practice and try and figure out which ones work. But essentially, try saying it out loud, and if it sounds kind of normal, then it's probably how you would do it. So nitrogenide doesn't sound right, but nitride kind of has a nicer ring to it. So try to find the one that sounds normal, and that's how you know where to put the IDE ending. So that, ladies and gentlemen, is an example of how you name them, but we have to go the opposite way. We have to be able to look at these names and go to their chemical formulas. So we're going to go backwards now. What you're going to do is you're going to write these steps in your notes and the examples as we go along, as there's no fill in the blanks. So make sure that you have these written down. So let's start with, and it's on the next page. So what we're going to do is chemical formulas. When you read the name of a chemical compound, you have to go kind of backwards. The first time it was like C5, for example, like we'll go over here. I said C5, put the prefix first. When we read it, when we read pentacarbon, we want to find the element first. Okay, so that's what we're going to do. We're going to find the element first and write its atomic symbol down, and then look at the prefix and put that number attached to it. So in my example of hexanitrogen triphosphide, I would start by finding my first element, which is nitrogen, and I would write its symbol down. So here's nitrogen, write the symbol. I would then go back and be like, okay, what is its prefix? Its prefix is hexa. So I'm going to go and I'm going to say, okay, hexa means 7. So I'm going to write N, and then I'm going to put a 7 beside it. All right. That is how you would read and convert to a chemical formula. Now we're not done because it has 2 elements that are supposed to be part of a compound. So we're going to read the second element, and we're going to attach its prefix to it after we find the second element. So in hexanitrogen triphosphide, phosphide is phosphorus. Okay, so we already have N7 written down. we're going to follow it by P for phosphide and 3 for tri. So in the end, your entire chemical formula that you're writing is N7P3. Now it's very, 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 very important. I will say that again, very, 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 very important that when you are done creating a chemical formula, you have to put a state beside it. For molecular, you can choose anything you want unless you know for sure it's a gas. So for me, I just picked a gas in this case because most molecular compounds are gases. So I just chose a gas, but some of them aren't, and that's okay. But you're just going to take a guess unless you know for sure what its actual state is. Otherwise, you're just going to pick a state in this case. So let's look at the practice here. I have nitrogen monoxide. So my first goal would be, what is the first one here? Well, nitrogen is an N. There's no prefix with it, so I just write just N. Oxide means oxygen. Mono means one. So rather than write O1, I'm just going to write just O. We don't need to write the number 1 down. It is implied because we have one atom of nitrogen and one atom of oxygen sitting there. Again, we don't use the mono on the first one, only on the second one. And then I'm going to add my state. Okay, I chose gas. Carbon tetrahydride, or its common name is methane. We're going to start here, carbon. So again, there's no prefix, so all I want to do is just write my first element down, just carbon. Hydride is hydrogen. Tetra, which I spelled wrong here. I said tetra, but it's supposed to say tetra, is 4. So I would write my hydrogen symbol first. Oh, sorry. I can't move this now. There we go. Hydrogen symbol first, followed by my 4, and then my state, which is gas. Hexaphosphorus octaoxide. What's my first element? Phosphorus. Does it have a prefix? Yes. So I'm going to start by writing the P and then adding the number beside it, which is 6 for hexa. Octaoxide. Oxide being oxygen. What is its prefix? Octa, which is 8. Add some sort of state behind it. All right. So ladies and gentlemen, in this lesson, you learned the importance of IUPAC, how to write a molecular formula, and how to figure out the prefixes, and then how to write the chemical formula. If you have any questions, please let me know.